So let's start. Just let me introduce myself first of all, please, just in a few words. So my first name is Quentin or Quentin. I'm actually the Africa sales manager for analytics, Xylem analytics, and especially for laboratory and process online measuring system for Africa. So please, in case you have any project in Africa and destination, you can contact me without any problem. Feel free to contact me. And I'm together with Georg, sitting in Germany at WTW factory, and he's actually our training and technical support. And I think he has something like more than 25 years experience in that field. So thanks a lot, Georg, for joining me to this webinar. Today's topic. So we divided the presentation into four, let's say, parts. I would just say a few words about Xylem, generally speaking, and then we will go through Xylem analytics. And then I will give the lead to my colleague Georg about the UV-Vis sensors and how it will work. How can we measure actually BOD and COD online? Then what could be interesting for you as well is to see a live demo in our lab in Germany. So basically, Georg will just give you some features on our transmitters and our sensors specifically and what we can do with them. Of course, we will have a question and answer session. So please feel free, don't be shy to ask all the questions you may have on the Q&A session. And we will answer actually to all these questions at the end of the presentation. And just as a reminder, this webinar is recorded, so you can at the end or some weeks later, you can share the record of this webinar to your colleagues or your customer, no problem. So just a few words about Xylem. What is Xylem? Xylem is an American group. Okay, global water technology, and we are dedicated mainly to water business. So that includes some very famous brand, for example, some like Flight or Godwin. We are manufacturing some pumps for wastewater application, but for dewatering as well. We are manufacturing some treatment for wastewater treatment plant. For example, with Vedeco or Sanitaire. But today's topic is about what we call Xylem analytics. And on this map, you can see our different factories and brands we have worldwide. Mainly, we are manufacturing our devices in Europe or in US, according to the brand and the application. To give you some example, for example, in Denmark, currently we are manufacturing some electromagnetic flow meters and some water level sensor for wastewater or drinking water application, for example, or even industrial application. In Mainz, in Germany, we are manufacturing some titration system. So in your laboratory, you can measure some specific parameters that could be interesting, such as manganese, magnesium, calcium, chlorine, etc., etc. So we do have several factories worldwide to supply analytics devices for your wastewater treatment plant, for example. In Africa, we have something like 5 offices in Morocco, where I'm sitting currently. I'm based in Casablanca, but we do have local Xylem offices as well in Egypt, Cote d'Ivoire, Kenya, or South Africa. Today's topic will be about WTW, so German brand, close to Munich, and WTW is dedicated to water analysis mainly, and we do have both, let's say, markets. So laboratory devices. Here you can have a look on the spectrophotometers that you can use in the lab or on the field. And I just would like to raise this point. We did some weeks ago or even months ago a webinar dedicated to optical reagent-free measurement. So basically how you can measure COD without a reagent. So if you have any interest on that, you can have a look on the recorded webinar. In addition to laboratory applications, we are manufacturing in Germany some what we call process or online measuring systems. So for having a continuous view on what is going on within your tanks or your wastewater treatment plants or your drinking water network. And this will be actually the focus of today. So now I will give the lead to my colleague, Georg, talking about the theory, about UV-Vis and the spectral sensors, and basically how we can measure BOD and COD online. So Georg, please, over to you.
Hello, good afternoon, good morning. Short introduction of myself. I'm the technical application specialist for this system. And now we will talk about how we can measure with UV-Vis and UV spectral sensors the different parameters. So next slide, please. Okay, what we have is we have a waterproof miniaturized UV-Vis or UV spectrometer. So we have two different hardware versions. We can measure from 200 to 720 nanometers, and the other one is from 200 to 390 nanometers. And the difference of both is the UV sensor can also detect NO2, and the UV-Vis sensor can detect TSS, total suspended solid, and color. And the theory principle or background is that we have special analysis models, special algorithm for municipal wastewater to calculate in the influent, aeration, and effluent. And so with this spectra, we can calculate the concentration of COD, TOC, BOD, DOC, NO3, NO2, suspended solid, and colors in milligram per liter. And here is the explanation why we need different sensors, especially if we want to separate NO2 and NO3, then you need a higher resolution of the wavelengths. So with the UV sensor, we have a resolution of 0.74 nanometers compared to the UV-Vis sensors with 2.07 nanometers. And with this small separation, it's possible to separate NO2 and NO3. And here you can see on the left side a spectrum, and you can see the range of the UV sensors and UV-Vis sensors. And you can see the areas where we can calculate the NO2, NO3 concentration, then the area where you can calculate the COD, the carbon parameters, and the area for turbidity. And important here is that only substances which absorb UV or UV light can be detected. So for example, if we have alcohol or sugar in the water, this is not possible to detect with this kind of technology. And here we have the comparison between multi-wavelength versus single wavelength sensors. So there are a lot of sensors in the market which measuring only on one wavelength. And you can see on the right side, if you have a single wavelength, then it's only a part of the complete picture. It's only one spot. And if you have a spectral measurement, you have an information about the whole picture. And based on this, the spectra have more information, and then you have more reliable data. This technology of spectral measurement is not new, but we have innovative things inside. So the first thing is we have a special optical design. And when you look at the two pictures on the right side, the VTV optic, the measurement channel, and the reference channel, all parts in between are 100% identical. And on typical conventional optics from competition, they have different design for measurement and reference channel. And based on this, we don't need a regular zeroing, because all of this is automatically compensated, every kind of drift of components. And based on this, we have high accuracy, high reliability, and a really long time stable measurement technology. The second point which we have is we have a called auto adjustment of the system. So what we make is we make a test flash with the lamp, we measure the signal strength on the detector, and based on this, we are using more or less flashes for one measurement. It means a clear sample, we need only a few flashes to get an accurate signal, and a dirty sample, we use more flashes to get this high accurate signal. And so based on this, we have no oversaturation and not a too low signal, absolute reliable data, and no regular manual sensor check is normally needed. So once again, few flashes for clear sample or low concentration, and multiple flashes if we have polluted sample or high concentration, automatically adjusted. Okay, I will hand over to Quentin again.
Yes, thank you, Georg. I just would like to say a few words about our features within our spectral sensors. So as you may already know, behind the measurement, we actually are using the Lambert-Beer law that it actually involves, let's say, what we call the path length. And please note that within our sensors, we have actually a fixed one, so either 1 or 5 millimeter gap. So basically, it will allow you to have reliable data because our gap, let's say, it's factory adjusted, okay, fixed and calibrated. So basically, about the data, it will be reliable. Then I can add as well that the material, I will say a few words later on, but it's extremely robust. You will see a picture then, and manufactured in a durable PEEK. Another nice features that is including within our sensors is about the internal ultrasonic cleaning. So basically, it will allow you to reduce dramatically the how often the technician or the engineer on the field will have to put out the sensor in order to clean it. Okay, and then another nice point is that with this ultrasonic cleaning, you will not have any moving parts or any additional spare parts. We have no wiper. Okay, so this ultrasonic cleaning, just for your information, is as well including within our sensors, measuring turbidity or TSS, for example. So it's a nice feature when it comes to talk about maintenance on the field. If you have what we can call a harsh application, we do have some additional accessories allowing you to actually inject some air from external air supplier, let's say, in order to clean more thoroughly the sensor and the measuring part. So basically, how it will work, if you have compressed air available in your wastewater treatment plants, you will just have to connect it to a specific module. So like, for example, this one, okay? And the specific module will have specific inlet for connecting your air, okay? And then you will install the modules directly into your existing system like that, like stack mounting, like a Lego, for example, okay? So basically we have such configuration, and then you can inject air close to the measuring window, let's say glass. If you do not have compressed air available within your field, we have accessories, what we call the cleaning air box, okay, that we can connect to our system, to our IQ sensor net, okay, in order to inject air again. So we do have accessories to offer if you have harsh application. Here, I just would like to show you a concrete example. So it's a picture that our colleague in UK actually shared on LinkedIn. It's just to show you how clean the measuring window is actually in comparison to the sensor that is being immersed into the tank. So just to show you that our cleaning technology is, let's say, efficient. Okay, I think it's interesting for you to know what is going on the field in the real, in a concrete example. Of course, automatic cleaning or even air injected, sometimes it's always nice to put out the sensor for maintenance. And you can do some what we call manual cleaning on the windows. According to your application, you will use this or this solvent, of course. We can advise you some specific solvent to use, but just to tell you that, yes, it's possible to clean the sensor manually as well, in addition to the automatic cleaning that you can do with ultrasonic cleaning or by injecting some air. Another nice feature, so we talk about harsh application, but you have to know by standard our spectral sensor are actually made of titanium. So this is very aggressive resistant, let's say, or corrosive resistant as well. So the glass, the optical windows is made by sapphire. So it will allow you to not have some scratch, for example, to the measuring surface. So basically we are trying to develop some sensors allowing you to reduce the maintenance and to have some sensor with a very high and important lifetime. Let me say a few words about accessories as well, about installation in the field. So we are offering several accessories. For example, you can imagine for a tank, for measuring into a tank, we can have some accessory allowing you to install the sensor vertically, but it's possible to install it horizontally as well. Then we do have, if you, for example, have heavily fluctuating water levels, we can imagine with our accessories, the set F that we call, having a kind of floating system that you will connect our sensor to in order to measure into a fluctuating water level. We do have a flow-through measurement accessories as well. So please, in case you have specific applications and you are interested in measuring several parameters, we talked about COD and BOD, but maybe nitrates, TSS, color, etc., through our UV-Vis sensors, please contact us and we will be happy to see what accessory is actually the most suitable for your application. So when it comes to application and real, let's say, life. So as you know, the backup of online measurements, usually you are using, let's say, more or less always the laboratory measurement as a reference, okay? So basically, that's why we did some exercise on the field, especially in Germany, where we are manufacturing our sensors, mentioning, yes, and comparing the lab measurement to the process measurement. And here on this graph, you can see that our online measurement is actually reliable in comparison to the lab measurement. What I can say, if I can add some information, on the top right picture, you can see 3 transmitters. So 3 of them are some WTW transmitters. One of them is actually installed since the 90s, so 9 zeros, and still working. And the other one is actually has been installed in 2002, I think, unless I'm mistaken. So just to tell you that, yes, we are trying to develop some sensors and transmitters working on a very long period of time. Another wastewater treatment plant that are using our COD sensors in influent and effluent measurement, just to give you some, yes, reference, let's say, a reference customer using our sensor for COD measurement. And here an example in Germany. Another example of application, the last one before the lab demo, is for NO3 measurement. Again, we have compared our spectral sensors with a lab measurement. And here you can see that we have an accurate measurement through online measuring system for effluent measurement in a wastewater treatment plant. So basically, it was just to give you an overview of our spectral sensor, the features, how it looks like, and how we can measure some parameters such as BOD or COD online. And now I suggest to give the lead to Georg again. At least he can show you the devices and the transmitter directly on the camera. So Georg, please, over to you.
Thank you, Quentin. So at first I want to show you what I have behind me to understand what I'm talking about. So what I have here is I have an IcoSensorNet demo system, a small one, and I have an UV-Vis sensor connected. So when you look on the sensor, you have the gap in between. So this is the point where we are measuring. And when you connect the sensor to the system, then you can see it on the screen. And I will move my camera a bit, so because then you can follow what I'm showing. I hope it's clear enough. So Quentin, please tell me if it's not clear enough. So here on the screen, you can see we have here a sensor measuring NO3, COD total, and of course, the second is also still COD total. What I would like to show is COD and BOD. And when you look on the screen, you can see a raw value. So this is the raw signal of our sensor. And then it's calculated to the actual concentration. And in this example, you can see that we can measure also NO3 and carbon parameters parallel. And basically, what you can see is that we simply calculate the raw value to milligram per liter. And when I go in the settings of the sensor, I can show you what else you can do inside the sensor and how to handle it. So this is the example for NO3. It's absolute identical if we measure COD or BOD or all the different parameters. So the structure is always the same. And what we can do here is we can change value pairs. So we can adjust the measurement and showing or comparing to the lab the results. And this is what I would like to show you how it works. So let's take this one. When you go on the C button, then it automatically frees the outputs. So it means all the milliamp signals and relay contacts are frozen. And then you can press OK. And you can go to the point single measurement. And I will jump out once again, because when you measure here, you have a T90 time, typically of 10 minutes. So the actual reading is a summary of the last 10 ones. And if you want to make a lab sample, then you need a single measurement. So you simply go to single measurement, pressing OK. And after you start this, it's the right moment to grab a sample. Because now in this moment, the sensor is measuring. And if I take a sample now, then it's a representative sample. And you see, it's a live demo. We have to wait a moment. Because now, let's say I have the sample in hand, I can note down the values here. And then I can go to the lab and make a lab measurement. I jump out of here. Because now I can say I have a raw value from the single measurement. I have a grab sample. I have the result from the lab. And then I can go back to the system and show, go to the settings of sensors. And when I go in here, then I can change the value pairs. So for example, if the raw value was 5 and the lab value was 10. So with these two value pairs, I can change the settings. And when I change settings, of course, don't forget to save and quit. And then this is the adjustment with value pairs. And so now you can see here, the value pair is the raw value is 0.5 and the calculated concentration is 1 milligram. So this is the simple, fast adjustment of the UV-Vis sensors compared to the lab. There are multiple more things what you can do with a sensor, but this is, I would say, the main thing, because you have to adjust it to the actual lab results. I can jump shortly again in the sensor settings. So let's go in here to see what else you can change. So we can change the measurement mode. We can change the location. So it means if it's inlet, outlet, or aeration. Then we can change the value pairs, what I showed you. When you have a carbon sensor, you can select how many carbon parameters you will want to display. So you can display, for example, COD and BOD parallel, or additional TOC or SAC. So all the carbon parameters, up to 5 parameters with one sensor. Then we have an automatic signal smoothing, which is normally on default of 10 minutes, because the measurement interval of the sensor is around about 1 minute. And to avoid jumpings from measurement to measurement, you normally activate a T90 time to get a stable signal. Then also we can set up the cleaning mode. So default is on and ultrasonic cleaning. And like Quentin explained, in harsh applications, you can also activate additional ultrasound and air cleaning. Okay, this was short about the setting points of the sensor. So once again, the main point is when you have the sensor, you have to adjust it to the lab with value pairs. We have also additional support like an Excel sheet where you can put in numbers. So if you want to do this, please contact us. And now I want to jump to the next point on handling. The point is what to do if we want to know is the sensor under proper condition or not. And for this, we have a simple method, checking the sensor with DI water. So I will move the camera to the sensor. So if we want to know if the sensor is under proper condition and clean, then you can put on a sensor sleeve, which you put over the gap and fix it. And then you can fill this with DI water. And before I start on the system, I want to explain, when you have filled it, you should knock careful to remove air bubbles. And now back to the system on the screen to see what you can do on the screen. Okay. Always the problem with adjusting the camera, of course. Okay, so if I want to check the sensor, you have to select it. You have to press the C button. And then you have the option sensor check. If you select sensor check in DI water, then the system tells you step on step what you have to do. So more or less you don't need a manual, because it tells you take it out from the sample, remove the compressed air hose if connected, clean it carefully, then pressing OK, I come back to the next step, put over the sensor sleeve and put it horizontal. And then it tells you put DI water inside, remove the air bubbles with slight knocking. And then I can start the measurement. So this is the simple method to check if the sensor is under proper condition or not. And you see it's a live demo. We need to wait again because it needs around about 20 seconds or 30 to get the result. And then it's a simple result. It shows you a rating number, which is actual 27, and it should be between -40 and +40. So it means now I directly have the feedback, this sensor is under perfect conditions. And I can jump out of here and switch off the maintenance condition. Okay, this was a short demonstration, what you can see and what you can do on the UV-Vis sensors. So I would say back to Quentin.
Yes, thank you, Georg, for this demonstration. So I will just share again my screen. And this is the end of this presentation. So I just would like to, let's say, asking you, first of all, would you like us to contact you, yes or no? And then we will actually answer the Q&A questions, okay? But first of all, please, in case you need any more information, or maybe you have some interest about measuring nitrate or COD, BOD on the lab, online, sorry, please feel free to contact us. So I just pop up the question, please answer yes or no, simply, and a specialist will contact you in your area. And then I will, together with Georg, answer the questions. So we have some, Georg, so it's nice to have some questions. So I give you some 30 seconds more, please, just to answer this poll question. It's always nice to see some interest, some yes, because I assume in your opinion, you are thinking about measuring BOD in 5 days in the lab, for example, or COD with a sample prep in the lab. So I think there is a question about that in the Q&A as well. So we will answer this question. So thank you. I will close the poll. And Georg, I suggest to go through the question and answers. So please, Georg. Yeah, we have a question about, do we have installation in pump station or manholes?
Okay, we have installations. I think it's not too many, because in this application, typically you have explosive zone, and then our sensor is not suitable. But of course, we have pump stations and manholes where we have installed our UV-Vis sensors.
Yeah, so please contact us again in case you have any needs in measuring online some parameters, and we would be happy to see how applicable it is, and if we are willing to or able to provide a solution for you. Another question, Georg, please. Does WTW have any experience in industrial wastewater, and what is the difference?
Okay, good question. Easy for me to answer. So we have a lot of experience also in industrial applications. The point is our algorithm is designed for municipal wastewater. So we cannot say basically it works in industrial application, but we have a lot of really good experience. So for example, only in India, we have more than 1,500 COD installed in industrial applications. So the only hint from my side is, if we want to go in industrial applications, be a bit careful, contact us, then we can talk about the details and look if it makes sense or not.
Yeah, thanks. Another question. So how come we are only seeing 2 parameters? I thought we will see all parameters on the screen.
Okay, this is based on the settings. So depend on how you make the settings of the sensor. You can see 1, 2, or up to 5 parameters in the screen.
Yeah, basically it depends, yes, as you said, on the settings and the sensor that we have, pH, conductivity, color, whatever. You can have several sensors connected to the same transmitters, and basically you will determine what parameters is interesting for you within your application. So to answer your question, yes, as Georg said, we can see only 2 parameters, but you can see up to, let's say, you can connect actually up to 20 sensors. So basically on the screen, you can set the respective parameters you want to be actually displayed on the screen. Another question about calibration. Can we calibrate the sensor with COD, BOD, TSS, TOC standard solution?
Okay, this is not possible. The reason is that we are measuring the spectra, and the spectra is application specific. And then you need a lab reference to make a real calibration or adjustment. With standard solutions, this is not possible.
Okay, thanks. Another question. How may sample taking require?
Good question. I always say as many as possible. So from the experience, 5 to 10 samples is a good start to have a reference and have the right value pairs for it.
Okay, another question with the lab method for measuring BOD, what we call BOD5. So how do you measure BOD with a sensor when BOD is based on change in oxygen concentration of a sample after 5 days incubation? Are you measuring organic carbon via UV and applying a calculation factor?
Okay. What we are doing is we have an algorithm. We are measuring the spectra and calculating the carbon concentration, basically. And then you can correlate this carbon value with the BOD from the lab. And then you can put like a calculation factor. So we are not using a factor, we are using value pairs, which means more or less the same.
Thank you. So it's very nice. We have a lot of questions, Georg. So it raised some interest. So thanks. Thank you, everybody. Don't be shy. Another question. What is the minimum life of a UV-Vis 7051?
Okay, the typical lifetime of our sensors is in the area of 5 to 15 years.
Okay, another question about flash lamp. So what will be the life of the flash lamp? So I think
it's the same answer. So I don't make a separation of the board or the LED or the flash lamp or so. So in general, our sensors are designed for a lifetime of typically 5 to 15 years.
Okay. And just a comment, it's not a question. And thank you for sharing this, this comment, George. So it's just raising that here in Greece, we have installed online COD in industrial application. So just to confirm what you said, Georg, earlier. So thanks for sharing this comment, George. Anil is asking the cost for in India. So please, Anil, send us an email. I will share with you the contact information, okay, of our colleague in India, and they will get back to you about the cost. So feel free to contact us. Another comment from George, again, thanks a lot, saying that actually for the industrial application, it was very successful and the sensors are amazing. So it's very nice to hear this feedback, George. Thanks a lot for this positive feedback. Another question, in DM water sample, what will be the COD and BOD?
Okay, DM water, I think you are talking about distilled or demineralized water. In this sample, you cannot use our algorithm. So it shows a value or a number, but the real concentration should be 0. And the mathematics are specialized for municipal wastewater. So you cannot compare what the measurement of COD or BOD should be in DI water.
Okay, another question about application, Georg, please.
Yeah.
Do we have any applications in lake monitoring or surface water, let's say, with telemetry consoles?
I'm not sure what you mean with telemetric consoles. So I know that we have multiple sensors in lake and river monitoring applications, and they are also connected to online platforms like databases to transfer the data.
I have a comment. We have, sorry, a comment from Richard about the 2020 controller that I have. So please, Richard, you are saying that you cannot link, or maybe you have, let's say, an issue with the controller. So please contact us again. I'm going to share our contact now, and we will investigate what could be the issue and what could come from it, actually, just to try to find a solution to your pending issue. Another solution about question, sorry, how to prepare COD solution in the lab.
Okay, at first, you don't prepare a COD solution in the lab to measure it with the sensor. What you have to do is you take a grab sample and then measure it in the lab. And to prepare this, it's depend on if we want to measure COD total or COD dissolved. If we want to measure COD dissolved, then you take a sample, filtrate it, and then measure it with a photometer in the lab. If you measure COD total, then you have to homogenize the sample and also measure it with a photometer in the lab.
Okay, thanks for this info. Another question, please, Georg. We have actually very nice questions. So thanks again there, all of you. Is the indicator can save the data? If yes, how many data can be saved?
Okay, easy question for me. We have a data logger integrated, which is free configurable. So you can say, I want to log every minute or 5 minutes or once per hour. And it can log up to 525,600 values, which means if you have one parameter, you can log every minute for 1 year.
Yeah, thanks. And just for, if I may, adding a comment, Georg, about collecting the data. We do have several modules like this one that you can stack mount to a transmitter in order to have some specific output. For example, if you would like to connect it to your SCADA system or your PLC system, for example, we have specific modules offering you the possibility to have, for example, Modbus, Profibus, 420 milliamp output. So basically, according to your needs and how you would like to collect data, we will offer you the suitable modules to stack mount to your transmitter. So basically, we can our solution is modular and adaptable to your needs. So please feel free to contact us in case you need to collect the data continuously. Another comment, please, Georg. Someone has a continuous flow, is asking actually, is vertical or horizontal position of the sensor matters?
Okay, let me take it in a different answer way. At first is why vertical or horizontal? So the horizontal method or position is needed if the water is not deep enough. So if you have only a water level of 20 centimeters, the optic needs to be inside the water. This is an argument for horizontal mounting. And when you talk about continuous flow, what is better, vertical or horizontal? My answer is that I recommend to have as much as possible flow in the optic area. Doesn't matter for me if vertical or horizontal. If you don't have flow, then maybe horizontal is better, giving air bubbles a chance to go out.
Okay, another question about COD. So we would like to know which organic compound which is not able to be detected in the COD as a certain of my customer, it's a chemical industry, wastewater application, seems to have not much of a reading compared to the DI.
Okay, if I understand the question correctly, is the question in chemical industry if the carbon compounds are reading similar or absorbing similar to DI water. And for example, like we showed in the presentation, and there are compounds which are not absorbing in the UV and UV-Vis area, like alcohol and sugar. If we have such an application, then we are out of the game, because these are substances the sensor is simply not seeing. If we are not sure, then I always recommend make a test on site and look if the signal or the result is good enough for the end user.
Okay. So yeah, what I suggest again is sending us an email about the application and what ingredient, let's say, could be in the wastewater to see if we can or not measure the content. A question about seawater. Is our spectral sensor suitable for seawater and aquaculture application?
Okay, give me a few seconds to answer it correctly, because I know I have the answer available, but I'm not 100% sure. So please, let's skip this question for later. And in the meantime, I will find the answer.
Okay, thank you. So another question, but it's a comment, an interest about the instrument has been raised. So please, Mr. Anil, contact us again, or we will have your email address, but feel free to contact us. And then our sales team locally will contact you back for having, for sharing with you the information you need. Do we have experience in desalination plants?
Me personal, no.
Yeah, from my side, if I may, adding a comment. So not necessarily for a COD, let's say, or BOD, but of course, we do have experience in desalination plant. For example, I'm based, as I said, as an introduction in Africa. And you know that the water scarcity is very important there. And we do have application about desalination, water reuse, etc. And you need to measure continuously what is going on in your process, and desalination plants is very important. It's becoming very important, especially in Morocco, in Egypt, for example. So to say yes, to answer your question, yes, we do have application in desalination plants for other measuring parameters, either in the lab or on online measuring system.
Okay, and
so you have the answer, right? about seawater?
Yes.
Okay,
I'm sorry.
Go ahead.
So I'm always careful with answers. If I'm sure, I say it. If I'm not sure, I check it. So back to the question, UV and UV-Vis sensors in seawater applications. So NO3 and NO2 algorithm are not suitable for such application. The carbon should work, but it needs to be tested. So we don't have active feedback. So from the theory, it should work, but we recommend to be on the safe side to test it. The same is for SAC and NOx. It could work, but also this needs to be tested. The other point is material. This is no problem because we have extreme robust materials, so you can use it in seawater application. And an additional small point is it's also possible that maybe manual cleaning is more often needed in such application. So short summarizing, carbon could work, SAC and NOx, but not NO3 and NO2.
Okay, thanks, Georg, for investigating. A question about, again, the display settings. I think we already answered this question, but please, for BOD, COD sensor, can we only see COD or BOD? And can we display both from the same sensor?
So you can see it both.
Yeah, both, or so yeah, it depends on the setting.
Yes.
Yeah.
I changed the setting on my system, so later in the session, maybe we have time to see it shortly. Okay.
Another question, what is the difference between SAC 254 dissolved and COD for UV-705 sensor?
Okay, short explanation. The UV-705 sensor is a one wavelength sensor measuring SAC, the spectral absorption coefficient, at 254 nanometers. And we can calculate from the SAC also with this sensor the COD dissolved. The COD DS is COD dissolved. So then it's a correlation between spectral absorbance to the COD concentration.
Okay, then about calibration with COD again, can we do a zero calibration of COD sensor using distilled water? Is it reliable?
It is possible, but not recommended. So the point is we have an extraordinary stable optics, and I recommend to make a check with DI water from time to time to be sure the optic is clean. I would not recommend a zero calibration. It is possible, but from experience, normally, if the rating number of the check mode is in the allowed range, then you don't need to make any zeroing. And if it's not in the allowed range, you should clean it again.
Okay, thanks. Another question. So is the sensor and transmitter explosion proof? ATEX?
Okay, simple answer, no. We have no explosive certification. It needs too much energy, so you cannot put it in explosive area.
And if I may adding a comment on that, Georg, we do have ATEX and sensor and transmitter, but not for spectral sensors. Okay, we can measure pH and conductivity in ATEX area. So not for this parameter we are talking about today, but for pH and conductivity, yes, it's possible. WTW, we are offering this, but only for pH and conductivity.
Okay, in the meantime, I switched my camera to my webcam, and here, for example, on this sensor, you can see now COD and BOD parallel with the same sensor.
Okay, so I don't know if people are seeing your screen, but okay, let's do later on. Maybe I will stop sharing my screen. Yeah. A question about ultrasonic cleaning. If ultrasonic cleaning off when sample reading is stable or increase during sample flow is off. I'm not sure if I understand the question.
Okay, I'm also not sure, but I can say a few words, maybe this answer it. So the method what we have is we have at first ultrasonic cleaning for I think 7 or 10 seconds, and then we switch off the ultrasonic to make the measurement so that the reading is stable and not interfered from ultrasonic.
Okay,
I hope
thanks.
this answer a bit.
Yeah, if it's not answering your question, please, again, you have our contact details here on this slide. Feel free to contact us, please, really. A question that we already answered about real-time data. So is indicator can save the data in real time? And if yes, how much data can be saved? So I think we already answered this question. So let's move to another one. Can the sensor measure high range COD value, especially from a brewery effluent?
Okay, hard question, because at first it's a special application brewery, so I don't know exactly which COD compounds are in there. And so my first answer would be, what is the specific range you have? And the second point is, I would make a test on site to be sure it's really working.
Yeah. So please, Jay, I suggest you to contact us, or even maybe our local team, Xylem local team, to try the sensor, or first of all, giving more detail about your application, and again, your ingredients you may have within your effluent. If a client can't afford a sensor net, do you have USB port to collect the data?
Of course. So I will change my camera again. Oh, better. You have it in hand.
I have a transmitter with some modules.
Yeah. So we have a USB connection standard on the terminal, and you can transfer the logged values.
And basically, you can use the USB port as well for software update that are available on our website on a daily basis. So yeah, we do have USB port. Is there any limitation of pH or temperature for a sensor or sample?
Okay, pH is between 4 and 12, the limitation. The temperature, I think it's 40 or 45 degrees. I think it's 40.
Yeah, I think so, yeah.
But this you could check on the homepage on the technical specifications.
In TOC measurement, which parameter actually is measured?
Okay, TOC is total organic carbon. So it means it's the complete carbon concentration in the water. And what we are doing, we measure the spectra and calculate the expected TOC value.
Okay, thanks. We do have a lot of questions. Thanks, Georg. But I think we are not, we are arriving at the top of the hour, but let's answering them. So what is the measuring time for measuring COD?
So the measuring cycle of the sensor for one measurement is 1 minute around.
Okay, so how 282.284 controller distinguish between the reading of TSS sensor and pH sensor signals? So it's not really about this sensor that we are presenting today, but maybe you can say a comment if you understand the question.
Okay, I'm sorry, I don't understand the question.
Yeah, me too.
One is the suspended solid sensor measuring the suspended solid concentration, and the other one is measuring pH.
Yeah, so please, if you can send us an email with your question, formulating in a different way, maybe we can answer with pleasure, of course. So yeah.
Okay, I think time is running, Quentin. I think to speed it up, I will take the questions and answers directly. Then it's maybe a bit faster. Okay, so there is a question if COD is effective working in wastewater estimation. It's designed for municipal wastewater. It's a simple answer. Yes, it works. Then it's a question about maximum chlorine concentration to avoid corrosion. So for the UV-Vis sensors with the titanium housing, there is no limitation. And the second is our plant made of stainless steel tank, and then corrosion spots below sensor observed. In this case, please come back with the details on an email to us, because it sounds like really a specific special situation. Then it's a question about costs for DO and BOD sensors in India. So I think this is back to the sales team. So I think they can contact you, Quentin, to get their contact in India.
Yes, please. Yeah, of course.
Okay, warranty period is basically the modules and terminals typically have 3 years warranty, the sensors 2 years, electrodes and things like this are maybe shorter. Then there is one question about troubleshooting for BOD. I think this is we should take offline. Please send us a short email and then we can talk about troubleshooting. Okay, it's going less and less.
Yeah, thanks.
There is one question about pH measurement. When they start calibration, sometimes it blocks it for measurement. So this sounds typically like an old electrode which needs to be replaced. If not, please contact us and we can go in details. And now one is left, service related, contact to India. The same feedback, please contact Quentin so he can forward this to our team in India.
Perfect. So there is no any more question. Thank you, Georg, for your efficiency. Taking the lead.
You're welcome.
Yeah. So thank you very much, everybody, for attending this webinar. Thanks, Georg, for your support and the nice live demo. We are available, and all the Xylem team worldwide to support you in case you need some trials to test the device, or if you need any advices about the application. Yeah, we are here to support you. So please feel free to contact us. And I'm wishing you a very nice day and talk to you soon. Thank you, Georg. Bye-bye.
You're welcome. Bye-bye.